All right, hello everybody. This is week 2 geometry. We're going to look at 7th grade geometry. Week 1 was 6th grade, week 2, 7th grade. So a lot of information here, but it's good information. So let's get started. Okay, so the first thing is we have this circle. Actually, if you look at it this way, 2 circles, you may do better. So we have the whole circle here, the red circle. All right, so the red circle. And you should know the area of a circle formula is pi r squared, right? Area of a circle is pi r squared. Also, the circumference of a circle is 2 pi r or pi d. Did you know that? But we're not going to use that right now. We're talking about area. We also have the smaller circle, which I will color blue. It's actually a white circle in the picture, but okay. So the circle that I colored blue is sitting on top of the circle that I colored red. So what should we do with these two areas to get only the outer ring? What we should do is subtract them. So red minus blue equals what I would like to call the outer ring. This guy. Okay, that's what that is. So that's how we're going to get it. And so now I'm just going to do the rest of the problem in black here. So the radius of the red circle is 6. It's going to be pi. Do you know what? The radius of the red circle is not 6, it's 9. See, the whole thing is 9. Okay, so 9 squared. And then the inner circle has a radius of 6. So then we do that. So we get 81 pi minus 36 pi. And then we subtract the 81 minus 36, which is 5, 4, 45. So I'm going to call it like that, 45 pi. Notice I'm not using 3.14 for approximation of pi, at least until I get my final answer. And where is my calculator around here? All right, I got one. But anyway, this is called an exact answer when you leave the pi in there. Exact answer. And now I'm going to put in, I'm actually going to use my pi button on the calculator. So I get 141.37. You use 3.14, 141.37. I use 3.14. I get 141.3. So we're going to do 141.37. And there we go. All right, that's enough about that one. A park has a large circle painted in the middle of the playground area. The circle is divided into 4 equal sections, and each section is painted a different color. The radius of the circle is 10 meters. All right, so this is an important question to do because we don't have a picture. So whenever you have word, real situation, you want to start by drawing a picture of it. So there I have my circle, and if it's divided into 4 equal sections, then we could do that, right? Just divide it, so something like that. And then each section is painted a different color. The radius is 10. So then you can imagine, what is the area of each section? So find the area and divide it by 4, right? So hopefully that makes sense. And just looking at that picture, makes it make a lot of sense. So draw a picture and make sense of the situation, and you'll do good. I'm not going to actually do this one, as you can see. Circle has a circumference, so use that circumference formula. Make sure you know the diameter is 2 times the radius. Find the arc length. We should talk about that. So arc length in geometry. So I'm going to give you the geometry formula, but then we're going to talk about this one in particular because this is 7th grade geometry. But in high school geometry, arc length is theta, which is a central angle, over 360 degrees times pi d, or 2 pi r. So this gives us a percentage of the circle, and we multiply that percentage by the circumference. Or you could do theta over 360 times 2 pi r, right? So we can see this one is, 25% of the circle, 1/4, right? So we know the radius is 7. So I would do, now hold on, we're gonna have to check on that crying baby. Okay, so this one would be 90 over 360 times 2 pi 7. We multiply that 2 and 7 to get 14 pi. Multiply that by 90 over 360, which is 1/4. So 14 pi. So put that over 1. And look at that. That could reduce to 7 and 2, right? So that would be 7 pi over 2. Another exact answer. And it says I could use the exact answer. So do that. 7 pi over 2. Ta-da! All right, area of the semicircle, you can do that. Okay. How many rotations? Okay, so yeah, what would the rotations be? Would that be area or circumference? Hopefully, think about the circumference is the area, the distance around the circle, and so rotating would be talking about that distance around the circle. So that would be the circumference formula. And I'm gonna let you figure that one out. Like, oh, Mr. Field, not that one, but you got to have some things to think about. Problem solve and put in the organizer and ask about it. Okay, so that's about circles. Now let's talk about angles here. Okay, so here we have 2 types of angles that you must know. The linear pair. I just went up there. She wasn't crying. Now she's crying again. I'm going back up. I'll be right back. Okay, so as I think I was saying, there are 2 types of angles you must know. The first is called a linear pair. Linear pair. The second are vertical angles. 1 and 2 here, but also 3 and 4. So 1, 2 angles, 1 and angle 2 is one vertical angle pair, and angle 3 and angle 4 is yet another vertical angle pair. Here 1 and 2 in this case are a linear pair. Why do we need to know them? Because the measure of angle 1 plus the measure of angle 2 equals 180. A straight line is 180 degrees. And here, angle 1 in this picture is congruent, or the same measure as angle 2. Also, angle 3 is congruent to the same measure as angle 4. So if we see an X in a figure, we know we have congruency. If we see two angles forming a line, we know they are adding to 180. That's called supplementary. We know they're supplementary. Two angles that add to 180. Complementary is two angles that add to 90. So here I can draw an X in this figure and I see that these two angles are vertical. So that means I can set up an equation like this. They're equal, they're congruent. And then you can just solve that equation. So what would that be? 80 equals 8x divided by 8. X equals 10. And then don't ever forget that sometimes we have to substitute that x back in to get the measure of the angle. But not in this case, they asked us what x equals. So that's how you do that. Aha, see, supplementary angles. I just told you that. They add to 180. So you could do that, figure out what they would be so that they would add to 180. Here again, this time, let's do this one. Looks a little tricky. So here I'm looking for my vertical angles and I'm looking for the supplementary angles. And okay, so this is what I'm going to do. This. Okay, so this side of the angle, I tell you, this baby is so upset. My youngest daughter. I'm pausing it again. Okay, so what we're gonna do here is we are taking this 160 and we are drawing a vertical angle with it, so that the red goes from the line AB all the way to this one. So that means that these two angles together form the other side of the vertical angle. So these two together add to 160, although that's probably not the easiest to see. If you can see it, they're the opposite side of the x. So we can set up this equation and then solve that. And that will be our answer. So what is 15 minus 60 of that? 45. So that means that that angle is 45. If I did the math right. Okay. All right. So go ahead and try that. Quiz 2. Okay. Quiz 3. Let's do some quiz 3. All right. A horizontal slice through a three-dimensional solid produces a two-dimensional shape. That's called a cross section. So if you think about a cylinder, like I'm a dad. What's your superpower mug here? It's a cylinder. And if I cut it right here, or if I just look at the top, it's a circle. That's called a cross section. So which one of these has a triangle when you slice it horizontally? A right here, you see the triangle base. It's the only one with the triangle base. So it's A. This triangle. Okay, so you might not know, but not all three number pairs can form a triangle. There's something called a triangle inequality, and that is if you have A, B, and C are sides of a triangle, any two sides of the triangle, if you add them together, should be greater than the third side. So if I add 4 and 5.6 together, that would be 9.6. So that means that this side has to be longer than 9.6. Well, shorter than 9.6. And if I subtract, sorry, shorter than 9.6. And if I subtract them, that gives me the minimum. So that would be 1.6. So this third side, in order for the three segments to make a triangle, it has to be bigger than 1.6, the difference of the two sides, and smaller than the sum of two sides. Okay, another cross section, you can do that one. All right, you can do that one. Oh, hey, now if you guess and you get it right, make sure you put in the organizer. Okay, so cross sections, triangle inequality. Let me just make sure the last one is, oh, hey, all right. And the last one, quiz 4. So lots of topics, but no pressure. We're just trying to get a survey of, skills you want to have going into high school geometry. And you'll have time to work on them during the year as well. It's just that if you go into the year with these skills, you'll be better off. In any skills that you acquire right now, you'll be better off. And knowing the ones you need to work on is also good. So what could be the length of the longer base of the scaled copy of the trapezoid? Okay, so the scaled copy of the trapezoid. So what we're going to do though is we're not going to do quiz 4. I'm going to add that to week 3 because I think this was a lot of content already. And so we'll add this one to week 3, and you guys just do quiz 1, 2, and 3 and have a great time.